Good evening everyone, this is Pavan Kumar, faculty of ACE Engineering Academy. So in this session, I am going to discuss about one particular topic and that too in permeability. Actually, the permeability is basis of the start of the actual concepts regarding to the geotechnical engineering. So one of the main problem that we deal with the soil mass is the seepage passing through the soil. That seepage can happen in the soil mass beneath the dam from upstream to downstream, or the seepage can happen in the canals if you don't provide any lining, or the seepage can happen when you excavate a trench below the water table and if you remove the water from the trench. So there is a possibility the seepage can happen. So but soil doesn't know whether the seepage is going to be friend or foe to it. So what water knows is to flow, and what soil knows is it has a voids, it will allow, and the permeability means the ability of a soil to permit the water. And soil doesn't know whether it is going to be good or bad in the future. So as an engineers and as a doctors to the soil mass, we have to know. So for that, first of all, we need to find out the permeability of the given soil mass. So as I said, ability of a soil to permit the water. And as soil consists of both solids and voids, the water can passes through the voids. And we know that different soils has different void spaces. Larger the void space, easy the what is for the water to flow. So for the soils with large void space will be having more permeability. In simple terms, you take a glass of water, you pour in the soil. If the water can flow easily without much effort, then the soil permeability is more. And if the water is taking a long time to flow into it, then the permeability is less. So in simple words, the soils with a large void space definitely consists of large particle size. Gravel has more permeability than the clays. In clays, the number of voids are more obviously, but each void space is less. So similarly, it can be the same if you discuss about the same soil with a different structure. So different soils has different permeability. But in the same soil, will the permeability is a constant? No. It is based on the denseness and it is based on the structural arrangement. If you take the cohesionless soils like sand, so sand has based on its relative density, it can be loose sand, it can be dense sand. In loose sand, the permeability is going to be more, and in dense sand, the permeability is going to be less. Similarly, if you see the structure wise for the clay, clay has two structures, one is a flocculated and other one is a dispersed. Whereas the flocculated structure has a more permeability than the dispersed structure. Overall, in and all, the permeability of a soil is not a constant property. It depends upon the type of soil, it depends upon the structural arrangement of the particles, it depends upon the irregularities between the particles. So now, in order to define this permeability, Darcy is the first person who studied the flow of water through the soil mass to define the permeability. So in this session, what I am going to discuss is how the permeability can be found out by means of its coefficient in the case of layered deposit. This topic is very important in the case of gate and ESC, and I say especially for the gate, because you see from 2022 to means from 2014 to 2021, 6 2 marks questions has been appeared in the single concept, and around 4 to 5 1 mark questions has been appeared from this concept. So it is one of the very highest weightage topic, especially in the permeability chapter. As in the previous session, which is a preparation strategy, I already mentioned you what level of models they can expect. Now we'll see that. So in this session, let's start with the Darcy's law. Darcy's law. Obviously, for any law, if it is a theory, they must have some assumptions. Without the assumptions, there is nothing. So we have to assume. So now, the Darcy is the first person he explained the free flow of water in the soil as a laminar flow. So, and he said that soil is fully saturated and flow should be laminar. So, in the case of the soils, if you want to say the flow is laminar, obviously whether the flow laminar or turbulent, it depends upon the Reynolds number. But the Reynolds number is not same in the all mediums. We see the flow in various mediums. We see the flow in pipe as pipe flow. We see the flow in open channel as open channel flow. And we see the flow in soil as a seepage. So here the common thing is flow, but variable is medium. As a type of medium changes, obviously the behavior of the fluid is also going to be changes. If you want to say laminar flow in pipes, the Reynolds number is less than 2000. Whereas in the case of open channel flow, it is less than 500. But in the case of particles, the flow between the particles, the Reynolds number is less than 1. So here if you want to say the flow is laminar in soils, the Reynolds number must be less than 1. So what this person has explained, sir? So this person explained that whatever the flow that happens through the soil, whatever the flow that passes through the soil mass. So let's take a soil element. Let's take the length of the soil element as A, L, and the cross section area of the soil element as A, assuming the flow is happening in the horizontal direction. If you take the flow in a vertical direction, then this L will behave like a cross sectional area and A will behave like a length, right? So let's assume that some amount of the flow rate is passing through the soil mass. What is the flow rate? See, when the water is passing through the soil, then definitely we need to find out that flow rate, that we can call it as a seepage loss rate. Okay. So whatever the flow passing through the soil from one point to another point, that depends upon how much head it loses over the length. Repeating again. So as per Darcy, what he mentioned is, whatever the flow rate passing through the soil per unit cross sectional area, flow rate passing through the soil per unit cross section area is proportional to whatever the head it loses when it flows over a length L. You know that when the flow is passing through the soil, the surface of the solid offers resistance. Due to that frictional resistance, we can see some losses. So that how you are going to measure that losses, sir? If we insert a piezometer at both the levels, definitely it shows the water level. So initially let's say the water level has risen here, but as the water flows, due to the head loss, the water level in the piezometer will falls. So let's say the water level has been rises up to this point only, and whatever this line, this is known as hydraulic gradient line, and the difference between these water levels is nothing but the head loss. And the slope of that hydraulic gradient line, we call it as a hydraulic gradient, which is H by L. So when flow is passing through the soil, the flow rate per unit cross section area depends on how much head is going to be lost per unit length, H by L. And from continuity equation, I know Q is equals to A into V. Can I write this Q by A as a V? And you know that H by L, head loss per unit length, is nothing but the hydraulic gradient. You see here, the velocity is proportional to I. What is the power? The power is 1. The power is 1 for the laminar flow. So actually, this V is directly proportional to I to the power of x, my dear, where x is equals to 1 in the case of laminar flow, and x is equals to around 0.65 in the case of turbulent flow. Okay. So eventually, as I required for the laminar flow, I will see the laminar flow only. So now if you observe here, V is directly proportional to the I. Yes. So V is directly proportional to the I. Then if you remove the proportionality, then V is equals to Ki. So now, yeah. So V is equals to Ki. What is this K, sir? This K is known as a coefficient of permeability. The K is nothing but the coefficient of permeability. So V is equals to K into I. But all this analysis the Darcy has done for the homogeneous soil. See, by default, if it is said or not said, by default we assume the soil is homogeneous, isotropic and semi-infinite. Apart from that, Darcy assumed soil is fully saturated and flow should be laminar. So as it is laminar, that x is equals to 1. So finally I got this V as V equals to K into I. And we call this V as discharge velocity or Darcian velocity. So once we know this V, then I can find out how much seepage is passing through the soil per unit time, which is nothing but flow rate. Q is equals to A into V, where V is nothing but Ki. So Q is equals to Kia. So this is the equation that we use to determine the seepage loss rate. When the seepage is happening through the soil, how much quantity we lose. If you send the water through the canal, if you don't provide any lining, then there is a seepage loss. How much loss you can see? Q is equals to Kia. I used to remember as a Q Kia. Q Kia. To find out the seepage losses, we use Q Kia. So, but if you want to find out this Q, you must need to know the K value, where K is nothing but the coefficient of permeability. And this coefficient of permeability has the same units which is equivalent to the units of the velocity. What is the units of velocity? Meter per second or centimeters per second or mm per second. So K will be also having the same units. Based on the K value, we do say whether the given soil is permeable or impermeable. If the K value is less than 10 to the power of minus 7 centimeters per second, soil is said to be impermeable. And if K value is more than 10 to the power of minus 1 centimeters per second, soil is said to be highly permeable. Highly permeable. Okay. So this is the concept given by the Darcy. But sir, you are saying this is homogeneous, but we want to discuss about the layered deposit. But in order to understand that layered deposit, you need to know this concept of Darcy, Q is equals to Kia. But one more point here, let's define the permeability once again. What is permeability? Ability of a soil to permit water through whom? Interconnected void spaces, which means the actual flow will happen through the voids. But while I am considering what is the area I have taken? What is the area I have taken? I have taken the total cross-section area. The total cross-section area consists of solids and voids. But the actual flow area is not total cross-section area. The actual flow area is area of voids. If I change the area, then velocity is also going to be changes, right? So now the true area is not the flow area. The true area is not the cross-section area. The true area is area of void. But if area of void changes, the velocity is also going to be changes. But flow rate remains same as per continuity. Q is equals to A1 V1 is equals to A2 V2. Flow rate should be same. But if area changes, the velocity also changes. Now the point is, total area is not the true area. Then Darcian velocity is not the true velocity. We call it as a superficial velocity. Then what is the true velocity, sir? The true velocity is nothing but seepage velocity. So once we know this, now you know that discharge is equals to A1 V1 is equals to A2 V2. If I take the total area, then the velocity is going to be the discharge velocity. And if I take the actual area, that is area of voids, and into Vs, where Vs is nothing but seepage velocity. and this is area of void, right? Now what we do is we rearrange the terms such that the seepage velocity is equals to area into velocity by area of voids. Now whatever the soil we see, this soil must be having certain length or not, L. Multiply with that length on both sides, or multiply and divide with the length. If you multiply and divide with the length, area into length, total volume. Area of voids into length, volume of voids. You bring the total volume to the denominator. Volume of voids to the total volume, that represents the porosity. So Vs is equals to V by N. Vs is equals to V by N. So now what is the true velocity? The true velocity is the seepage velocity. But sir, in examination, should I go for the Darcian velocity or should I go for the seepage velocity? Look, if you are looking for finding the flow rate, if the examiner asks you to find out the flow rate, you don't need to worry about anything, because the flow rate is nothing but area into velocity, this product, and area of voids into seepage velocity. Both products are same. But if I go for Vs, I need area of voids. You tell me, do we know the area of voids? Can we see the voids? No. Instead of going for area of voids, I take total area, I take total velocity. Eventually, the product of these two is same as area of voids and seepage velocity. So if I ask you what is the seepage loss rate happening, I don't need to worry about the seepage velocity. Just I'll find out the Darcian velocity. So what is the Darcian velocity he mentioned? The Darcian velocity is V is equals to Ki. And once I know the Ki, then I can find out multiplying with the area. But if they ask about if the water is going to be traveling from one point to another point, A to B, over a certain length L, what is the time required? What is the time required to travel from A to B? Now when I ask you the time, that is the actual time, you have to use the actual velocity. So there you need to find out the seepage velocity. What is seepage velocity? Length by time. But can I find out seepage velocity directly? No. First I'll find out the Darcian velocity, V by N. What is N? Porosity. So in examination, if they do ask about the time required to travel, then you simply find out by using the seepage velocity. So seepage velocity is nothing but length by, so time is equals to length by seepage velocity. So when you use seepage velocity, if they ask the time required to move from one point to other point, but if they ask seepage loss rate, you don't need to worry about anything, simply use the Darcian velocity. So this is the concept of the Darcy's law. Apart from this, there are some validations. So Darcy's law is valid when the flow is going to be the laminar flow, and that laminar flow can be seen only in the case of soils finer than 425 micrometers, and on an average we say 500 micrometers, which are nothing but fine sands, silts and clays. So now using this concept, let's come to the main concept. Layered deposits. Layered deposit, or we can also call it as a stratified deposit. Stratified deposit. So let's take our friend dam. Let me take a gravity dam. This is the upstream bed level and here it is the downstream bed level. So upstream water level and downstream water level. Now whatever the soil below the ground level, it need not be homogeneous or isotropic. In reality, it won't be. It will be as a layered deposit. Ground level to first 0.5 meter, the soil will be different, and later on the soil will be different. Now, let's say there are some two layers of the soil is there. Let me take this is soil 1. Let me take this is soil 2. So now, in order to analyze this one, see what Darcy's law said is soil is homogeneous. Now what we do is, for analysis, here also we assume one thing. Each and every layer is individually homogeneous. What is the meaning of that one, sir? If you take soil 1, the soil 1 is homogeneous. which means in soil 1 at any point its permeability same. Soil 2 is also homogeneous. In soil 2 its permeability is also same, but the permeability of the soil 1 and soil 2 are not going to be same. Okay. So let's represent the permeability coefficient for the soil 1 as a K1 and permeability coefficient for the soil 2 as a K2. Now these two soils are there. Two soils has different permeabilities. Now you see, due to the difference between the water levels, definitely flow starts to happen through the soil. And as it is a laminar flow means layer by layer. So flow is going to be happen, either the flow can happen directly beneath the dam like this, or the flow can pass through the soils and it can again go into the downstream like this. Likewise, throughout the soil the flow can be happening. But if you observe clearly, when the flow is happening, there are two things that are happening. One is a simultaneous flow and other one is one after another. Let me say in this way. You see, this is soil 1 and this is soil 2. And whatever this interface between the soil 1 and soil 2, can I call it as a bedding plane? Bedding plane or boundary. Bedding plane or boundary. So if you take this one as soil 1, soil 2, this is a bedding plane. And when the flow is happening, you know the flow takes place from higher energy level to lower energy level. That's it. That's true. That is there. I don't need to explain. And when the flow is happening, you see, this flow first, it can happen perpendicular to the bedding plane. Yes. And once it is happening perpendicular, then the flow will happen through the beneath the soil. And while the flow is happening here, you see in soil 1 and soil 2, the flow is going to be happen simultaneously. So first flow perpendicular to the bedding plane, and then there is a flow parallel to the bedding plane. Mind it, I am not saying vertical or horizontal. I am saying flow perpendicular to the bedding plane and parallel to the bedding plane. If you see the flow perpendicular to the bedding plane, this is soil 1, this is soil 2. First the flow will pass through soil 1 and then the flow will pass through the soil 2. Is it simultaneous flow or one after another? One after another. But when I see the flow passing through the parallel to the bedding plane, so here this point and this point, at the same points flow is going to be happen simultaneously. Now the soil 1 has a different permeability, soil 2 has different permeability. When the flow goes from 1 to 2, the behavior will change. Then the permeability quotient also changes or not? Yes. Let me take whatever the average permeability quotient when the flow is perpendicular to bedding planes as Ky. Similarly, when the flow is happening through the parallel to the bedding plane, again here the flow is happening simultaneously. When the flow is happening simultaneously, again in that direction also the permeability will be different. So now here this is a Kx. So what is this Kx and Ky, sir? I give you n number of soils. In all the soils, when flow happens parallel, that is a simultaneous flow. So different soils has a different permeability. What is the average permeability of that soil in that direction? What is the direction? Parallel to the bedding planes, Kx. Similarly, when flow passes from 1 to 2, 2 to 3, perpendicular to the plane, the permeability keep on changing. So what is the permeability? Ky. The question is, does Kx and Ky both are same? If both are same, then there is no meaning of layer deposit. I can say it as a homogeneous. But as we are discussing about the layer deposit, the Kx is not equals to Ky. The Kx is not equals to Ky. So then how these are related, sir? Kx is generally greater than Ky except Lewis. So Lewis is a windlaid deposit where the permeability quotient of the soil when flow parallel to bedding planes is less than the permeability when flow perpendicular to the bedding planes. So this Kx represents parallel to bedding planes. So average permeability. And this Ky represents average permeability parallel to bedding planes. And in these two also, this is perpendicular to the bedding planes. So in these two also, the most important one is the perpendicular to the bedding planes. Let me see with the perpendicular bedding planes. Why I used Darcy's law? Why I have explained the Darcy's law? Now, I told you for analysis, each and every layer is assumed as a homogeneous. When I assume each and every layer is independently homogeneous, I can apply Darcy's law for each and every layer independently. Okay? So now let's see what happens when the flow is perpendicular to the bedding planes. When flow perpendicular to bedding planes. When the flow is perpendicular to the bedding planes, let me take the same example where I have taken some two-layered deposit. Let's take out that soil sample and we'll see. Okay? So let's take, this is some sample and it consists of some two layers. One is soil 1 and the other one is soil 2. Now, let's say flow is perpendicular to the bedding plane. Flow perpendicular bedding plane means what is bedding plane? Interface between the two layers. This is the bedding plane. Yes? Now you tell me, does the flow is going to be happen simultaneously or one after another? One after another. Let's say some flow rate is Q passing through the soil. When I say flow is perpendicular to the bedding plane, first of all this entire flow has to travel to the soil 1 and then from there to soil 2 and then there comes out. Does it just looks like a flow in a pipes connected in series? Flow in pipes connected in the series. So you release some flow rate that will pass through pipe 1 and pipe 2 is connected in series that pass through pipe 2, pipe 3 connected in series that pass through pipe 3. In all the pipes the flow rate is same. Similarly here also flow rate passing through soil 1, flow rate passing through soil 2 and out of flow, whatever the flow that comes out, all flows are same. Assuming there is no seepage losses in the soil. Okay, so entire flow comes out. Now what is the condition over here? The condition is Q is equals to Q1 equals to Q2. All flow rates are same. What does it mean by Q1, sir? Flow passing through soil 1, flow passing through soil 2. Outer also it is going to be same. Number 1, the flow rate passing through each and every soil is same. When the flow is going to be happens like this, then this is going to be the cross section area, right? If you take a plane, the plane of each soil, so when the flow is happening, this plane is going to be same for all the soils, right? The plane area that's going to be same for all the soils. So I can write area is equals to A1 is equals to A2. When the flow is perpendicular bedding planes, flow rate is same, area is also same. Sir, if flow rate same, area same, then as per continuity equation, A1 V1 equals to A2 V2, A3 V3, area same. Then I can write velocities are also same. And this is the logic that we need. Keep that in your mind. I say logic because I am going to apply it as a logic in the examination. Okay, so every time it's not about the equation. So let's first find out the equation and then we'll see how it is going to be beautifully applicable to the questions. Now, if you observe here, I'm telling you whatever the flow velocity when the flow is perpendicular to bedding planes, that average velocity is there, that velocity is same in the soil 1 and in the soil 2. But I told you the soil is individually homogeneous. Can I apply the Darcy's law? Yes. As per Darcy's law, V is equals to Ki. Ki means, so V represents the average velocity, then K y into I. What does it mean by Ky? Ky means average permeability coefficient when the flow is perpendicular to the bedding planes. And what is I? I means head loss per unit length. So let me take the soil 1 thickness as Z1. Let me take soil 2 thickness as Z2. Now everybody, you tell me, from the start point to this end point, what is the total distance the water will travel? Z1 plus Z2. And when it travels from 1 to 2, this point, you see here, when the soil is travelled the entire distance of Z1, definitely, so when the water travels from a top point to the Z1, definitely the water loses its energy. Let's say you started, you walk for some distance, obviously your energy will lose. And if you walk further, you will lose much more energy. So from this point to this point, the distance you travel is Z1, head loss is H1. Here Z2, head loss is H2. What is the total length you travel? Z1 plus Z2. What is the total head you lost? In Z1 H1, in Z2 H2. H1 plus H2. So as Z different, H different, I value is also different, right? I told you the velocity is same, not the hydraulic gradient. So Ky into I is equals to, for soil 1, K1, I1. For soil 2, K2, I2. This is the logic, my dear. That's the logic. But sir, I require some equations, sir. Can you please get down some equation? So I need an equation such that I can find out the Ky value directly. Okay. So if you want to find out that equation, let's see. Okay. So this is condition number 1. Condition number 2, the total head loss is equals to H1 plus H2, because first the water has to travel Z1 and then Z2. Okay. So now if it is a head loss H1 plus H2, then you know that each layer is individually homogeneous, so I can use Darcy. Q is equals to Kia. I can be written as H by L into A. Can I write H as QL by Ka? Yes. QL by Ka. Then what is H? The total flow rate into, what is the total distance that travelled by the water? Z1 plus Z2 by Ky into area is equals to, for the H1, head loss in soil 1, flow rate in the soil 1, seepage length in the soil 1. What is this L represents? L represents seepage length. If the seepage is happening vertical, L becomes Z. If the seepage is horizontal, horizontal length. If the seepage is inclined length. So Q1 Z1 by K1 into A1 plus Q2 Z2 by K2 into A2. Now, you see here, from the condition number 1, can I cancel down the Q1, Q2, Q3 and areas also? Yes, QA, Q1, A1, Q2, A2. Now finally I can write this Ky as Z1 plus Z2 by Z1 by K1 plus Z2 by K2. This is the equation for the flow perpendicular to the bedding planes. Flow perpendicular to the bedding planes. Okay. So how it came, sir? You send the Ky to the other side, the remaining to here, and I can, in simple words, I can write this one as Ky is equals to summation of the seepage length. Summation of the seepage length. Here Z represents the seepage length by Z by K. Z by K. Okay. So here, one way, this is a logic. Logically, when the flow perpendicular to bedding planes, I say velocities are same, discharge same, area same. So product of K into I must be same. Or else I can give you the equation directly. Sometimes the equation will give the results earlier, sometimes the logic will give the results first. So this is how we need to find out the permeability when flow is, which case I am discussing here? I am discussing the case of a flow perpendicular to the bedding planes. For the flow perpendicular to the bedding planes, see, mind you, here I am representing soil 1, soil 2 as one by one. Somewhere the soils can be next to each other. It's not about horizontal flow, it's not about vertical flow. It's about whether the flow is perpendicular to bedding planes or parallel to bedding planes. Similarly, we can work out for flow parallel to bedding planes. So just like how I have explained, you can go through the flow parallel to bedding planes also, but I am not going to discuss about that. My point is about focusing the flow perpendicular to bedding planes. So once a flow perpendicular to bedding planes, I can say that the velocities of flow in all the soils are same, or else I can find out the Ky as summation of Z by summation of Z by K. Okay. So now there are two permeabilities, Kx and Ky. You know how to find out Ky now. In the similar fashion, you can find out the Kx. But those represents the different directions. But I want the equivalent permeability. This is a layered deposit. You found the equivalent permeability in flow parallel to bedding planes and perpendicular bedding planes. What is the total equivalent permeability? The total equivalent permeability, Ke is equals to geometric mean of the Kx and Ky. See, the difference between the Kx and Ky is very large. Due to that difference, instead of arithmetic mean, we go for the geometric mean. What is Ke? Equivalent permeability. This is a layered deposit or anisotropic soil also we can say. The equivalent isotropic deposit permeability is square root of Kx into Ky. Okay. So these are the topics. First we discussed about the Darcy's law. So as per Darcy's law, V is directly proportional to I power x, that x is equals to 1 for laminar. But as we are discussing about the laminar flow, so we take V is equals to Ki, and then we find out how to find out the seepage loss rate, Q Kia. But we got to know that velocity is not the true velocity. The true velocity is the seepage velocity. But we don't need to worry about which velocity be to used in finding the flow rate. You can use either V or Vs. If you go for the discharge velocity, you use total area. If you go for the seepage velocity, you use area of voids. But eventually it's always better to use A into V, because finding area is very easy than the area of voids. But if they would have asked the time required for the water particle to travel from one point to another point or over certain distance, you have to go for the seepage velocity only, because that's a true velocity that represents the true time. Okay. And by using this concept, I explained how the flow is going to be happen parallel to bedding planes and perpendicular bedding planes. Parallel average Kx, perpendicular Ky, and equivalent is root of Kx into Ky. And how to find out when the flow is perpendicular to the bedding planes. So first, all flow rates are same, this is the logic. And as head loss is summation total, this is the equation. So let's see some of the previous gate questions as a 1 mark question and 2 marks question that has been appeared previously. So let me have some water.
And used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then, last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then, last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online.
Now, let's see the previous gate questions. First, one more question based on the topic that we have discussed. A soil mass has a coefficients of horizontal and vertical permeabilities. See, in general, we take the flow parallel to bedding planes as a horizontal, but perpendicular to bedding planes as a vertical. But what I say is, don't remember in that way. So most of the cases we see the layered deposit as one by one. That's the reason why. So we assume here Kx as a Kh and Ky as a Kv. Horizontal and vertical permeabilities are 9 into 10 to the power of minus 7 centimeters per second and 4 into 10 to the power of minus 7 centimeters per second. If you wish to see also, if you get a doubt, you check both permeabilities. I told you the flow parallel to bedding plane, Kx is always more than the flow perpendicular to the bedding planes. So what I am asking you is the transformed coefficient of permeability of an equivalent isotropic soil mass. Whatever the layer deposit, we call it as anisotropic soil also. But if you convert that equivalent, finally, you know the equivalent permeability Ke is equals to square root of Kx into Ky. Okay. So square root of Kx into Ky. So square root of 9 into 10 to the power of minus 7 into 4 into 10 to the power of minus 7. So 9 4s 36, square root of 6. Square root of 36, 6 into 10 to the power of minus 7 centimeters per second. There is a question that you can do without using calculator also. So 9 4, 9 4 36, square root of 36, 6. The correct answer is 6 into 10 to the power of minus 7 centimeters per second. So this was asked in long back gate, gate 1997. Now let's see the next question. See this question. According to Darcy's law, flow through porous media, the porous media here is the soil, the velocity is proportional to. So what he mentioned, velocity is proportional to whom? Head loss per unit length. How much head the water losses if it travel 1 meter is nothing but the hydraulic gradient. So it is directly proportional to whom? Hydraulic gradient. So that's what mentioned by the Darcy. Option B. Next. Which of the following statements is true for the relation between the discharge velocity and the seepage velocity? So I explained you the discharge velocity. Later on we got to know that's a superficial velocity and the true velocity is the seepage velocity. So they were giving the relation. Seepage velocity is always smaller than discharge velocity, can never be smaller, equal or no relation. So they are asking about which is smaller, which is larger. Let's see. What is the relation between the seepage velocity? Vs is equals to V by N. You see N is nothing but porosity. What is porosity? Percentage of voids. Does percentage of voids can be 100%? If the percentage of void is 100%, then entire soil is a void. We are not discussing about soil. So if you do remember the range of the porosity, what is this N? The N is nothing but porosity, which represents the percentage of voids. The range of N is 0 less than N less than 1. So N value will never be equals to 1. If N value will never be equals to 1 and that is lesser, as N value is less than 1, then the seepage velocity obviously will be more than the discharge velocity. So always seepage velocity is more than the discharge velocity. I have a relation, and in that relation, which is more? Seepage velocity is more. Or else you can say in the other way also. You know discharge Q is equals to area into V is equals to area of voids into seepage velocity. You know flow rate same, product should be same, and if one value decrease, other value should increase. Yes, compared to total area, area of voids is less. If area decrease, to make the product constant, if area decrease, seepage velocity should increase, which means seepage velocity is obviously more than the discharge velocity. See the options? Seepage velocity is always smaller than discharge velocity? No. Seepage velocity can never be smaller than the discharge velocity? Yes. It can never be smaller than the discharge velocity. Seepage velocity is equals to? No. No relation between seepage velocity and discharge velocity can be established. No, there's a relation. So what is the correct answer? The correct answer is option B. This is a 1 mark question from GATE 2015 set 1. Okay. Now you see this question which was previously asked GATE 2020 set 1. Velocity of flow is proportional to first power of the hydraulic gradient. What is the meaning of velocity of flow proportional to first power of the hydraulic gradient? That is nothing but x is equals to 1. When I say x is equals to 1, then that represents laminar flow, right? A laminar flow in porous media. If I say turbulent flow, that should be 0.65. Laminar as well as turbulent, no. Transition, no. So that represents the transition means 0.65 to 1, but they are clearly mentioned power 1. So the correct answer is laminar flow. These are the 1 mark questions that has been appeared. I took a few, but these are not the whole questions. There are a lot of other questions also. But I want you to understand the concept, how they are framing the question. So now let's see the 2 marks questions also. This is one of the very beautiful question. The question seems to be tricky, but it has nothing in it if you understand the concept. Let's see what they're asking. You observe the seepage occurring through a porous media shown in the figure. So this is a porous media. The hydraulic conductivity, you see the permeability can also call it as, means coefficient of permeability can also be called as hydraulic conductivity, or in given as meter per day. So if the data is visible to you, fine, else I will write once again. So whatever the permeability they have given, K1, you see there is an impervious strata and there is a higher water level here, there is a lower water level here, and there is some difference between the water levels. What is the difference? This is 15 meters and here it is 10 meters. So that difference is 5 meters. The difference is 5 meters. Okay. And if you observe, there is a porous media. So this is a porous media. Yes. And this is also a porous media. Yes. And this is also a porous media. Okay. So there are 3 soils are there. 3 soils are there having 3 permeabilities. K1 is given as 2 meter per day. K2 is given as 3 meter per day. And K3 is given as 1 meter per day. So they just gave you the values and they mentioned in terms of meter per day. Now it is a layered deposit or anisotropic soil. Yes, and different soils are there. Now what I am asking you here is the seepage discharge through the porous media at section PQ. So I am asking you, this is section PQ. At this section PQ, what is the seepage flow rate? First thing first, when you see these type of questions, we need to understand how the flow is actually happening. So if you forget about what to do here, you will be out of coverage area. First thing, whether the flow is parallel to bedding plane or perpendicular to bedding plane. Here comes, I did not mention you remember it as horizontal or vertical. Why? Because I'll tell you now. This is soil 1. What is meant by boundary or bedding plane? This is the bedding plane between the soil 1 and soil 2. What is the length of the soil 1? 20 meters. And soil 2, whose permeability is 3 meter per day. And what is the length of the soil 2? 10 plus 20, 30 meters. And soil 3, 10 meters. Array, these soils are next to each other, na? when the flow is going to be happen, the flow has to come over here and the entire water has to travel through soil 1 first. Okay. Then the same water will pass through the soil 2, yes. Then the same water will go through the soil 3 also, and finally it comes over here. Now you tell me, if I resolve this, now if I draw this separately, so 3 different soils. So this is soil 1, this is soil 2, and this is soil 3. The flow is happening how? Does the flow is happening perpendicular to the bedding plane or parallel to the bedding plane? It is a horizontal flow, but it is not parallel to the bedding plane, because this is nothing but the bedding planes. These are the bedding planes. And now if you have understood this point, you would be knowing what is the question I am asking you. I am asking you, what is the flow rate at section PQ? Arre bhai, as the flow is a perpendicular bedding planes, same flow will pass through soil 1. Same flow will pass through soil 2, which means at any section you take, it doesn't bother me. All the flow rates are same. So flow rate passing through, total flow rate Q I send is equals to Q1 is equals to Q2 is equals to Q3 is equals to discharge at a section PQ. If I find out the total flow rate, that's it, fine. But for that you need to understand whether the flow is perpendicular to bedding planes and are parallel to bedding planes. Hope you understood that. So now I can simply say from here, whatever the total flow rate is nothing but flow rate passing through the PQ. So now let's see how to find out the flow rate passing through the soil. Now flow rate passing through the soil, total flow rate, right? What is the total head loss I have? 5 meters. What is the total head loss I have? 5 meters. What is the total length? L1, L2 and L3. L1, L2 and L3. Okay, so now let's see. Whatever the total flow rate is nothing but flow perpendicular to bedding planes, total I and total area. Yes. Do I know the, see, if I want to find out, I can write it as a K1I1A1 also, K1I1A1, K2I2A2. But do I know the head loss, especially in soil 1? I don't know. So that's the reason why what I do is I'll find out what is the average permeability of all the soils. As the flow is a perpendicular to bedding plane, I know this Ky is nothing but summation of Z by K. But do remember, here I have given you the Z as a length. So what is the first soil length? This is 10 meters. What is second soil length? This is 30 meters is given, and this is a third soil which is again 10 meters. Have a look. So 20, 10 and 10. So this is 20. Now the seepage is happening from here to here. In the earlier case where I explained by taking the vertical. Here I am explaining the horizontal, but the concept should be same. So that sigma z means there the seepage length is depth. Here the horizontal seepage length is horizontal length. Add upon all those. So what is sigma z? 20 plus 30 plus 10 by z by k. So I have given you the k1, 2, k2, 3, k3 as 1. Z by k. 20 by 2 plus 30 by 3 plus 10 by 1. So what is the ky that we got? 20 plus 30 plus 10, 60 by 30, which is equals to 2 meter per day. So what is the average we got? The average is 2 meter per day. So keep that in your mind, my dear. You know there are two types of permeabilities, parallel and perpendicular. You need to be aware which one to be used. Just because you would have remembered it as horizontal flow, fasak, out of the coverage area. Tata, bye bye. Now here we got the ky, fine. Once I know the ky, then what is our total flow rate? At PQ is equals to 2 meter into What is the total length that traveled? Total head loss is 5 meters and total length is L1 plus L2 plus L3 because I am taking the total flow rate. At any section is same, na? So I take total length, I will take total head loss. So this is total of 60 meters, right? So 2 into 5 by 60 into what is area? You see this? If you observe here, this is the flow area or not? 3 meters thickness. 3 meters thickness. So now I have taken this is a 3 meters thickness. So if it is a 3 meters thickness, flow rate is Q. What is the flow area? 3 into perpendicular board 1. Three into 1, right? So now 3, 20, 2, 10, 5 by 10, the answer is going to be 1 by 2. 1 by 2 meter cube per second. What is the flow rate passing through any section? Whether it is soil 1, whether it is soil 2, whether it is soil 2, at any section, as flow perpendicular bedding planes, flow rate is same. The answer is going to be 1 by 2. This is the question and the answer is B, which is equals to 1 by 2. Hope you understood the concept. Hope you understood the concept, okay? So the question is all about if you understand what to do, then you will get to know. If you don't understand what is happening, though you know the equations, it doesn't matter. So here I use this question, I use the equation, then I have solved. Now let me give you one more question where I don't use the formula also. So now this question, it was asked in GATE 2018, set to 2. From 2015 onwards, 15, 16, 18, 19, 20, 21. In all these 5 papers, there was a out of 4 papers, 2 marks questions has been came. And you know what, in GATE 2018, set to 1, 2 marks question from permeability, set to 2 also from permeability. So I took this question. I am not saying about the set 1, this is set to 2. So let me go with this question first, okay. So let's see this question. So this is a 3-layer deposit. Now 3 soil specimens, soil 1, soil 2, soil 3, each are 150 mm long. So the length of the each specimen is 150 mm. So L1, L2, L3 all having same 150 mm. Keep that in your mind. And 100 mm diameter. So each soil diameter is also there, 100 mm diameter, such that I can find out the area if I required. Are placed in series in a constant head flow setup. You know when the pipes are connected in series, similarly flow perpendicular to the bedding planes. Suitable screens are provided at the boundaries of the specimens. So there are some suitable screens are provided, these are the boundaries. The values of coefficient of permeability of soil 1, soil 2, soil 3 are 0.01, 0.003, 0.003, 0.03, the value of H in the setup. You see the figure, they have given a constant head setup, which means they maintain the same difference between the water levels. Okay, whatever the total difference between the water levels is given as capital H, which is how much? 560 mm was given. You know that here flow takes place from higher level to the lower level. Again you tell me, does the flow is parallel to bedding plane or perpendicular bedding plane? Again this is to fool you. This is the horizontal flow, but is it parallel to bedding plane? No. Here this is a bedding plane and the same flow rate will pass through the soil 1. After that the same will pass through the soil 2. After that the same will pass through the soil 3. Here I am not asking you the flow rate. What I am asking you here is, so from here to here water level has been fallen down, which means there must be some head loss. Let me take it as H1, okay. And from here to here, how much distance you are traveling? You are going to travel the length of 150 mm. Then there must be one more head loss. This is going to be the H2. And from here to here, there must be one more head loss, that is nothing but H. So let me take it as a H3. So total head loss over here is in soil 1 H1, soil 2 H2, soil 3 H3. The question I am asking you here is, what is this small h? The question is the value of h in the setup. That h I am taking as a h3. You know, each and every soil, when the flow happening, there is a head loss. What is the total head loss? 560 mm. Total head loss is 560 mm. So I want h3 if the total head loss is 560 mm. Now you have two options. So what you have to do? Now I want a total head loss. Okay, fine. First thing first, I see this is a layered deposit. So I have to check whether it is a flow parallel to bedding plane or perpendicular to bedding plane. If you forget about that also, fine. You see the flow happening. Same flow is happening all the soils, which means flow is perpendicular to the bedding planes concept. Okay. So now you see here, as same flow passes, I can write Q is equals to Q1 is equals to Q2 is equals to Q3, all soils, and I can write areas are also going to be same, and I can write velocity is also going to be same. V1 is equals to V2 is equals to V3. Okay. Now if you observe here, the velocity is also going to be the same. So what is velocities? Ky into I is equals to K1 I1 is equals to K2 I2 is equals to K3 I3. Still I haven't applied the concept. Let's go back once again. I have given you the permeabilities of all soils. I have given you the permeability of soil 1, soil 2, soil 3, 0.01, 0.003, 0.03. And you see here 100 mm screens were provided at the boundaries. Now the value of the h in the setup. So how to find out the value of the h? Let's see. I want to find out this h, right? Now this is the logic I have, and I mentioned you all the lengths are also same, right? So what I'll do is, I'll take two things at a time. I will take two things at a time, all are same. I will take two things at a time, and I'll try to write H1, H2 in terms of H3. I will try to write H1 in terms of H3, H2 in terms of H3. How, sir? Let's see now. What I will do is, as I require the H3, first I will take K1 I1 is equals to K3 H3, K3 I3, K1 into H1 by L1, K3 into H3 by L3. You know the lengths are same, right? And I know the permeabilities. What is a K1? 0.01. What is K3? 0.03. Now 0.01 into H1 is equals to 0.03 into H3. Can I write that H1 as, if you send there, 3 times of H3? Yes. Such that I am trying to convert the total equation of head loss in terms of H3. By taking K1, I can find out H1. Similarly, you take K2 I2. Lengths are same, na? K2 I2, which means H2 by L2 is equals to K3 H3 by L3. I am not using the equation, I am using the logic. I am not finding the Ky. I don't need to worry about the Ky also. I will explain you that way also. So now K2 H2 is equals to K3 H3. K2 is 0.003, H2 is equals to K3, 0.03 H3. Then what is H2? What is H2? 0.003 by 0.03 by 0.003. It comes as 10 times of H3. You see, what I have done is, I wrote H1 in terms of H3. I wrote H2 in terms of H3. Now what I have to do? I need to find out the H3. That's what I am looking for. This water level is H1. From here to here is H2. What they are asking is the final difference, this H. I am taking it as a H3. So now what I do is just simply add up all everything. You know that total head loss is equals to H1 plus H2 plus H3 is equals to 560 mm. H1 is 3H3, H2 is 10H3. So 3H3 plus 10H3 plus H3 is equals to 560. Then H3 is, that's total of 14 H3, right? 560 by 14. 14 fours, right? 14 fours, which means 40 here. What is the H3 value? 40 mm. Just by applying the logic. The logic is when flow is perpendicular to the bedding plane, or if the same flow rate is passing, area also same, velocity is also same, as simple as that, equate the velocities. Why to waste our time to find out the ky again? Why to use the equation? Sir, can I get the value by using equation? Yes, you can. But when there is a less time taking, then why do we waste our time, right? So this is one of the approach. I just use the logics, I converted everything in terms of the H3 and I find out the value. Even I haven't utilized any calculator here. The only step that I used here, even this also doesn't require the calculator. So now see the question, what is the answer? The answer is 40 mm. I hope you understood these models. Yes? Sir, what if I want to go with the equation, sir? Yes, you can go with the equation. That's also there. How, sir? Now again, you go to the logic. You see the logic. This is logic, right? What I do is, I equate ky into I as K3I3. Our focus is all about the H3, right? So what I do is now, ky into I is equals to K3I3. So ky into the total head loss by total length is equals to K3 into H3 by L3. You know the total length? The total length is L1 plus L2 plus L3 because the flow has to travel all the length 150 plus 150 plus 150, 450 mm. And what is L3? 150 mm. Now you see here, I know the total head loss. This is 560 mm. I know L3. I know K3 also. I want H3. For that I need to find out first ky, right? You need to find out the ky. Sir, how can I find out the ky? You can find out the ky. Ky is equals to summation of z by summation of z by k. Keep that in your mind here. The z is not depth, that is the seepage length. Now there are three things right here. So now if you find out that ky, the ky is equals to, yeah, so you know all the permeabilities, but they are in terms of the centimeters per second. They are in terms of the centimeters per second, okay. So you must have to convert these things in terms of centimeters. 150, 150, 150, centimeter, 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 na? So everything is 15 centimeters. So you can write either 150 mm or 15 centimeters. Now 15 plus 15 plus 15. What is this 15, sir? 150 mm I am writing in terms of centimeters because I have given the k value in terms of centimeters per second, okay. So 15 by k1 as 0.01 and plus 15 by 0.003 plus 15 by 0.03. This requires a calculation, right? 45, take out the 15, take out the 15. So ky is equals to 45 divided by, take out the 15 into 1 by 0.01, which is nothing but 100. Yes, 100 plus 1 by, see this is 0.003. So 1000 by 3, 1000 by 3, 1000 by 3, okay. So 1000 by 3, 333.3 plus 15, sorry. Yeah, we have taken the 15 outside, right? Or else we'll do one thing. We'll find out like this itself. And we'll say at the end, Okay, so don't take out anything. Yeah, 15 by 100. So 1500 plus 15 by 1000 into, means if it comes to the numerator 15 to 1000. So this is going to be 5000 plus 15 by 0.03. Again, it comes as 500. 1500 plus 500, 2000, 2000 plus 5000, 7000. So 45 by 7000. 45 by 7000. Hare, you need to do calculation, right? Without calculator, I cannot solve this one. Now, you find out the ky, you substitute here ky, and you find out the h value, means h value is there, L value is there, K3 is also there. What is K3? 0.03. You can find out the H3. This is one way, and this is one more way. So I hope you understood the two models. My whole point of view is how to apply the Darcy's law and how it should be applied for the flow perpendicular to the bedding planes. These are the two perfect examples I took. So these are not the only things. They have asked some 5 to 6 questions. If you see the previous gate papers, you will get to know. Okay, so in this question, same, but here I applied the equation and I got the value. In this question, I applied the logic, I got the value, and I am explaining you how to get by using the equation also. Hope this session helped you to understand the way that you can get the questions regarding to the permeability, especially in the layered deposit. I am stressing out again, from permeability, 70 to 80% of probability they can ask from layered deposit. So in this session I discussed only about the flow perpendicular to the bedding planes, and flow parallel to bedding planes. It won't take much time. You can go through the notes, or you can go through my earlier videos. So in the Deep Learn or ACE online platform, you can get the videos. Yeah. So I hope you understood this session well, and it really made some impact for you. And we have launched very good programs. We are all there in all the 3 platforms: online, offline, and recording. So if you have any queries, you can ask, you can post in the comments. That's all with this session. So Tata, good night.
Question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik, and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik, and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik, and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation,